Hello, good morning, good afternoon, good evening. How you guys doing? I hope you are doing great. I wish you a wonderful day. Yeah, in this video, we are going to look at regression analysis and goodness fit tests. We'll just solve a very simple example. But before we do so, let's just pray. Just pray to our God individually for 2 seconds. Pray for retentive memory and more understanding. We are in prayers. Amen. Okay, yeah, prayer is very necessary. So in case today is your first time of meeting me, go to Google and type Remjock Maths. You will see a lot of solved problems with solutions. Not only that, you will also see mathematics comprehensive lecture notes for those of you who are preparing for NECO, WAEC, GC, NC, JAM, ND, HND, BSc, Masters up to PhD level. You will see comprehensive mathematics lecture notes with solved problems, and you will see a lot of mathematics. People have been testifying about this website. It will do you good. Then you can also follow me on Facebook. Type this, you will see me. Facebook, Twitter, TikTok. Go to YouTube. You can also follow me. Please, this video, don't just watch. Try and share this video. Thank you and God bless you. Okay, let's look at this. Yeah, it's simple as ABC. Given the table, this is the table, number of sixes, expected constants, observed constants. We have number of sixes. It means this number of sixes is talking about x0, x0, x1, x2, and x3. Amen. Okay, so you will see 0, 1, 2, 3. We have 58, 34, 7, 0.5. We have 47, 45, 15, 3. Then it says evaluate b of n equals to 3, p equals to 1 all over 6, which is equals to n factorial over n minus x factorial, p raised to power x, open bracket 1 minus p raised to the powers of n minus x factorial, where x run from 0 to what? 3. It's simple as ABC. I'm going to show you already the variables have been given here. So what we need to do, it means when we say x equals to 0 to 3, we are talking about this number of sixes, 0, 1, 2, 3. So at x equals to x not equals to 0, you must obtain the value of this. So let's write solution. Amen. Alright, solution n factorial, isn't it? N factorial all over n minus x factorial times x factorial p raised to the powers of x, in bracket 1 minus p, all in bracket n raised to the powers of x. Amen. So when you come across this, already your n has been given, where, amen, n equals to 3, p equals to 1 all over 6, x, and at x equals to what? 0. Because when x equals to 0, so let's substitute in. This is equals to our n is what? 3. So 3 factorial all over 3 minus 0, 3 minus 0, all in bracket factorial, then x is 0 factorial, then p is 1 all over, so 1 all over 6 raised to the powers of x is what? 0. Are you following? Okay. Then 1 minus 1 all over 6, n is 3, 3 raised to the powers of minus x is what? 0. Amen? So far, so good. Okay. Yeah. Okay. So this is the same thing as 3 factorial all over 3 minus 0 is 3 factorial times 0 factorial, true or false? Then here, in mathematics, anything raised to power 0, even if 1 million or 1000 raised to power 0 is what? 1. Take note. So as you can see, we have 1 all over 6 raised to power 0. Is that clear? So this is equals to 1. So take note. So for that, here is 1. Amen. Then here we look for the LCM. If we have 1 minus 1 all over 6, note that the LCM here is 6. 6 to 6, 1 times 6, 6 minus 6 to 6 is 1 times 1. So here will now be what? 6 minus 1 is 5 all over 6. So times 5 all over 6 raised to the power of 0. 3 minus 0 is 3. Okay. So here will now be, I hope you are following. So here will now be equals to, when we say 3 factorial, 3 factorial means 3 times 2 times 1. So take note. So 3 factorial here is 3 times 2 times 1 all over 3 factorial again, 3 times 2 times 1. Then note that 0 factorial is always equals to 1. Take note. Are you following? So here will be times 1. Okay? Then times 1 times when we have all in bracket raised to 5 all over 6. This means that 5 raised to the power of 3 all over 6 raised to the power of 3. And this is the same thing as 5 times 5 times 5 all over 6 times 6 times 6. Amen? Yeah. Is that clear? Okay. So here we are going to have 5 times 5, 25. Then 25 times 5, 125, right? 25 carry 1, 10 plus 2, carry 2 plus 12. So 12, 125 all over 6 times 6, 36 times 6 again is 216. So this is what? 216. Yeah. Okay. So far so good. So here will now be equals to, this is equals to this and this will go. We left with 1 to multiply this. We discovered that we have 125, then 216. Yeah, that is at x equals to 0. So we have to consider at x equals to 1. Okay, so it means where our n is equals to this. So when at x equals to 1, it is only the x variable who varies. It will vary this way from 0, 1, 2 to the top. That is what we are trying to do. But the next, the other variables, n and p, they are constant. So take note. So now okay, for the sake of malleance, let's do it this way, where n equals to 3, p equals to 1 all over 6, and at x equals to what? 1, isn't it? X1 is equals to 1. So It means here will now be this formula. N is 3 factorial all over n is 3 minus 1 factorial times 1 factorial, since x is 1. Then p is 1 all over 6 raised to the powers of 1. Do you agree with me? Then times 1 minus p. This is 1 all over 6 raised to the powers of 3 minus our x is 1. So here will now be equals to 3 factorial all over 2 factorial times 1 factorial, true or false. Then 1 all over 6 raised to power 1 is the same thing. It's going to give 1 all over 6 times this one will give you the same thing here, 5 all over 6, 5 all over 6. 3 minus 1 is raised to power 2. Then here we are going to have, we'll have, I told you 3 factorials means what? 3 times 2 times 1. Then what of 2 factorials? 2 factorials mean 2 times 1. Is that clear? So if you agree with me, 3 times 2 times 1 all over 2 times 1 times 1 factorial 1. Then here is 1 all over 6, amen, times what we have 5 all over 6 raised to the power of 2. This is the same as 5 times 5 all over 6 times 6. This is equal to 25 all over 36. Do you agree with me? Okay, so here will be 25 all over 36. Yeah. So far so good. This and this will go. So if you can see what I am saying, this to 871 to 6 2. So we have 1 all over 2, amen, times 25 all over 36. Then if we use this to multiply out, this will give us 25 all over 72. Yeah. So this is at x equals to 1, amen. Are you following? Then let's consider at x equals to 2. Can we clean this part? This part, right? You can clean this part, right? So here we change it to 2. No more 0. So at x equals to 2. If at x equals to 2, let's try this again. It's the same way, but just that the x value will vary. Is that clear? So this will be equals to, amen, this will be equals to, at x, this is n is 3, so 3 factorial all over n, 3 minus n is 2, 2 factorial times 2 factorial. Then our p is what? 1 all over 6 raised to the power x is 2. Then open bracket 1 minus 1 all over 6. Then close bracket 3 minus 2, because your x is what? 2. So far so good. This will now give us 3 factorial all over 3 minus 2 is 1 factorial times 2 factorial. Then 1 all over 6 raised to power 2 means 1 all over 6 raised to power 2 means 1 all over 6 times 1 all over 6. This is equal to 1 times 1. It's going to give you 1 all over 6 times 6, 36. So here will be 1 all over 36, amen, times, here we're still going to give you the same 5 all over 6. Is that clear? So 5 all over 6, in bracket raised to 3 minus 2 is 1. It's not necessary to write the 1. So far so good. So this is we can now write 3 factorial. I told you that that 3 factorial is 3 times 2 times 1 all over 1 times, since we have 1 factorial, 1 times 2 factorial, we're going to do a 2 times 1, then times 1 all over, 36, times 5 all over 6, amen. If you can see what I am saying, this and this will cancel, 3 all over 1 is 3, 3 to itself 1, 3 to 6 is going to give you what? 2, isn't it? So it means we have this is equals to 1 all over 36 times 5 all over 2, which is equals to 5 all over 72, because 36 times 2 is going to give you 72. This is for at x equals to 2. Then the last but not the least, let's consider at s equals to 3, which is this. So we don't know whether we will arrive at that is yeah. Okay, so can I clean this side? Yeah. So far so good. If at x equals to, it means where n equals to 3, p equals to 1 all over 6, then and at x will now be equals to 3. So this is the formula. We are still making use of this formula. Our n factorial, n is what? 3. 3 factorial is equals to all over 3 minus 3 factorial times 3 factorial, because x is 3. That is why your n is 3. Then times p. P is 1 all over 6. Your x here, look at it, x is 3 raised to the power 3. Then times 1 minus 1 all over 6. N is 3 minus x is 3. So far so good. This is equals to 3 factorial all over, amen. 3 minus 3 is going to give you what? 0. 0 factorial, 3 factorial, then 1 all over 6 raised to the power 3. Open bracket, this one will still give you 5 all over what? 6. Because if you take the LCM, is that clear? So 5 all over 6, 3 minus 3, 0, raised to the power 0. You know, I told you anything raised to the power 0 is 1. So here will be 1. Then 3 factorial is 3 times 2 times 1 all over. 0 factorial is 1 times 3 factorial, 3 times 2 times 1. Amen. Then when we have 1 all over 6 raised to the power of 3, this is the same as 1 all over 6 times 1 all over 6 times 1 all over 6. So this will give you 1 all over 216. Take note. So here will be 1 all over 216. Then times here will be 1. Because anything raised to the power 0 is 1. Take note. So if you agree with me, this will going to give us this and this will go 1 divided 1, 1. This is 1 all over 216 times 1 is the same thing as 1 all over 216. This is how you are going to use this formula to obtain your x naught to x3. Should in case you come across something like this in any of goodness of fit tests, this is how you are going to approach it. Thank you and God bless you. Please don't forget to share this video. Make sure you share this video. This is an assignment to someone and the person is looking for this solution. I love you. See you in the next video. Bye. Yeah.